want you to make the connection between the other four trig function and tangent and cotangent. They're very, very, very similar. So one more time here. If I do tell you that that blank is filled by sine or cosine, how do you find the amplitude? Absolute value of it. How do you find the period? It's 2 pi over b. How do you find the phase shift? If you've memorized negative d over b, or you can pull the b out of the quantity. That's one way. Or you can set it equal to 0 and solve it. There's like a bazillion ways to do this, whichever one you like best. I don't care. And then lastly, vertical shift is what? C. It is C. Okay. Did anything change if that was secant or cosecant? No. No? Yeah, amplitude. The amplitude did. Yeah. There is not an amplitude, but everything else stayed the same. And if you have not filled this in on the top of the back side of your journal, you might want to be doing that soon, since journals are due next class. Oh, geez. This is only a 3-day chapter. So, oops, I'm not down here. It's not a bad test, usually. All right, so then, today we are going to add in here tangents and cotangents. And we're going to get the graph created first, and then I'll ask you what we need to change, if anything we need to change on that list. Okay, first time we're going to graph this baby with the coordinates off the special angle table. Well, that's good. So, and since half of you have now done your special angles, you should be good at your special angles in radians. So, what's the tangent column? What? 0. 0. Yeah. Undefined. And I'll tell you the square root of 3 is about 1.7. Square root of 3 over 3 is about 5.56. So it's a little bit, slightly above a half. Okay, so we're going to plot those, just ordinary. And so 0, 0 is no big deal. Because I don't know why there's a random yellow square on the graph. It won't erase.
I think you interrupted.
Okay. Ciao. I think your pen dried. Okay. Oh, okay, it probably did. So if that's 0, 0, pi over 6, I'm going to go up 0.56. On these boxes, how much up is that? A little over 1 unit up. Yeah, it'd be just a smidge above the half. And then pi over 4 is the number we like, because it's a nice even 1. Pi over 3 is at 1.7, which would actually be a little over 3 boxes up. And then how do you graph undefined? Asymptote. So pi over 3 is an asymptote. So if I connect the dots, where do I go after this last point? Yeah, you just go up the asymptote. Now, you think that's it? Tangent is a little half curve?
Yeah, no, it's a scrabble up.
It is like a scrabble up.
Sure.
So the other points for it are actually over here on the left of 0.
Why is it like a scrabble up?
And if you think about it, if you put a negative on all those angles, if all those angles are negative, that means I'm going which way on the clock?
Negative. Backwards.
I'm going backwards. But if it's got a 6 on the bottom, isn't it always square root of 3 over 3?
Yeah.
So it's going to be that exact same number, except it went backwards. We're in the 4th quadrant. What is tangent in the 4th quadrant? It is negative. So therefore, if we do all these other points, they're all just simply going to be negatives. So you're going to plot the exact same points. You're going to go negative pi over 6 over, down just a little over a half. Negative pi over 4 is going to be at 1. Then you're going to get your 1.7. And pi over 2 is going to be another asymptote. And so when you,
I love Scrabble.
now,
They're my favorite.
tangents don't tend to have quite as much bend in the middle as a Scrabble does. They're a little straighter, I guess, but that's the closest thing we can get to them. Do you think, actually, let me ask a second question. Is there more to that graph? Do I need to plot some more points over here to the right? What do you think it does after this? It repeats itself. So you could just repeat it over and over and over. Well, all the trig graphs are periodic.
Understandable.
So they all repeat. In tangent's case, remember tangent's positive in the top. No, it's not. Sorry. It's positive, negative, positive, negative. So you go through a positive quadrant, then it comes back down here and goes negative, positive, negative, to positive, and it just keeps doing those little scrabblers.
What are these used for?
Well, actually, if we get a whole bunch on the graph, particularly if you graph them on your calculator, I don't know if I...
Bunch of waves.
It looks like something you see in the medical world. Yeah, it looks like heartbeats, particularly if it connects the asymptotes. Then it comes up again, connects.
That's a crazy heartbeat. Actually, it looks pretty normal. Drop off.
So, that would be one application of it. Okay. Isaac just asked me a good question. Back on the topic. Isaac just asked me if it was a negative in front, if it was a negative tangent, negative amplitude. What's that graph going to do? Flip the other way. So it's just, yeah, it's just going to fall. It's going to be a downward traveler.
Yeah, I don't think we have enough recipe designed in trigonometry.
If we didn't have connections to trigonometry, why would we have discovered it?
You think God meant to?
I think God has an amazing...
He's a genius, I know that.
Yeah. And look at all the math that backs up everything.
Oh, I think people just made up math.
I know.
Oh, why?
Okay. All right. I'm going to draw the next set of points. Actually, I want to ask you, what would be, once again, you only have to graph 5 important points on here to graph a tangent. What would be those 5 points you need? Okay. You're right. It's going to be the asymptote, the center of it. What would be the other points that are the easiest to plot? The one and negative one, which just happen to conveniently be exactly in the middle of your other 2 points. So you're going to actually find your 5 points the same way you did before. You're going to take 1/4 the period. It all works exactly the same way.
So this is really nothing new.
The shape is new, and there's a couple little twists here. The biggest twist probably, what's the period of that graph? That's one period of it. How wide? Is it 2 pi wide like all the others?
That's pi and a half. I can't tell.
That's a negative half. That's a positive half.
That's 2 pi.
A half plus a half
That's pi.
is 1 pi. So the period on tangent is only pi instead of 2 pi. So when you do your little formula sheet here,
Is it pi or whatever it is?
it is pi over b, yes.
Whoa.
Does it have an amplitude?
No. No. No.
It's going infinitely up forever and down forever, so no. The only trig functions that have to have amplitude are sine and cosine because they're waves.
Does that mean no amplitude or not applicable?
It means not applicable.
So you did answer that tangent and cotangent have a use, but what you did never answer secant and cosecant. They don't really have a use, do they?
Not as much as the sine and cosine. There are places I'm drawing a blank at the moment. There's a real world where you have something shifts and then it goes down, but they're not real common, no. Okay. The other 2 things, your phase shift and your vertical shift, still the same. Do those the same every single time. So the main thing you have to know is that the period on tangent is pi over b. 1 pi, not 2 pi. Okay, there's going to be a couple other things you have to know too here in a sec. Okay, I am going to, if I wanted to put another period of that on there, now that you know the period is pi, if the center is 0, where's the next center?
Pi.
Pi. And if this asymptote is at pi over 2, where's the next asymptote? 3 pi over 2, yes. You just keep going over pi, and you got it. So, and we could then plot, we are only going to plot the little halfway spots, which I didn't emphasize here. We're going to plot, change color. We're going to plot the 1 and negative 1 points, and that's all you're going to plot. So in this case, at 3 pi over 4, I would go down 1, and at 5 pi over 4, I would go up 1. Alright. The other key thing you have to know about tangent and cotangent, just like with sine and cosine, you have to know where it starts. In this case, tangent, the key point you have to know on tangent, guys, Eli isn't going to hear a thing. No. If, when you phase shift whatever is at the center. So in this case, since the actual center of the tangent is at 0, when you do a phase shift, if you have a phase shift of pi over 4, that means the center point is going to be located at pi over 4. So that's kind of crucial. Thank you. So tangent shifts its center. That's going to be crucial for you when you go to find your 5 points. Okay, cotangent does not shift its center. We can figure out cotangent in 3 minutes here. Think about it. If you do the reciprocal of these points.
Can you go back to the other screen?
No.
Yes, I can go back to this.
You, Alex?
No.
Right fast and stop talking. Okay, I can do this relatively quickly. Cotangent's the reciprocal. So if you take this point that's undefined and you do cotangent, you have to do the reciprocal of undefined. What's the reciprocal of undefined? 0. So cotangent would have 0 right there. It'd have its center point there. If I do the reciprocal of this negative 1, reciprocal of negative 1 would be still negative 1. So it would still be right there. Reciprocal of this 0 center point, that would be undefined. So that would, on cotangent, you would have an asymptote sitting there. So cotangent actually just comes downward instead of going upward. It's the exact same point, it just comes downward. But you have to realize cotangent puts its asymptote on the origin, not its center point.
Wait, so cotangent puts the asymptote on the...
Well, so when you go to phase shift, a cotangent, you're shifting its asymptote to that new number.
And you start on the asymptote.
So
does that have to be an open circle then?
there's an well, yeah, or just draw the asymptote. So cotangent shifts its asymptote. If you can keep that, basically those two things straight, you do pi over b, and what part of it shifts, tangent shifts its center, cotangent shifts its asymptote, you can pretty much read tangent and cotangent. They're not that difficult. Because everything else is the exact same thing you've been doing. So let us try one. Alright, we are going to try y equals 2 times the tangent of 3/2 x minus pi over 2. Oh, whoa! I forgot, we got to stop. Eli, we have to stop before 15 minutes.